In this video, we're going to be using superposition to find this voltage V. So superposition is useful when you have multiple sources, so independent sources. And what it's going to tell us is how much voltage V is caused by this 10 volt and also how much voltage V is caused by this 1 amp. In general, this isn't going to be your fastest method, but it is useful for seeing kind of the contribution of each of your independent sources. So if you remember, the general form is something that looks like f of x1 plus x2 will become f of x1 plus f of x2. And so that's assuming we have linear equations. All of our elements are linear, so we're good there. I'll generally rewrite this to look something more like, so in this case, we're trying to find a voltage V. So you would have V is equal to V1 plus V2. And then the way that I learned it was with primes. So it's the same thing. So V prime plus V double prime. And if we had a third source here, a third independent source, then I would add a V3 or a V triple prime. So I'll use this to solve. And the process is we pick one of these sources and we turn all the other independent sources off. And what will happen, so in this case we don't have any dependent sources, so these will simplify down to things like voltage divider and current divider most of the time. So we have our 10 volt source. Our current source, when we turn it off, we will have 0 amps here, which is the same thing as an open circuit. So there's no current flowing through here, so it's as if a wire doesn't exist. So we can basically just erase this entire thing. Oops, I forgot to add our resistor. So there's a resistor here. It is 100 ohms. We have our 10 ohm resistor here, and we have our voltage across it. So this is not the entire voltage V. I'm going to call this V prime. You could also call it V1 if you wanted to. Our goal now is to find V prime, which will be how much voltage is caused by the 10 volt source. You'll see that we have some resistors in series. This is a voltage divider problem. So voltage divider is Vx equal V Rx over Re. That's our generic form. In this case, our Vx is V prime. Our voltage is 10. If you check the polarity, you'll see that we go from negative to positive and we go positive to negative. So what that means is basically we increase the voltage and then we're going to drop the voltage and we're going to drop the voltage again. So our polarity is fine. We don't need to make this a negative 10. The voltage that we care about is across a 10 ohm resistor, and then our total is 10 plus 100 since they're in series. And then you solve this and you will find that you get 100 over 110 or 10 over 11 volts. And so we need to do this again because there are two sources, so we need to redraw the circuit again, this time with only the 1 amp circuit on. The 1 amp source on. So make sure you get the arrow going down, otherwise it'll be a different circuit. Over here, we have our plus or minus V. In this case, I'm going to call this V double prime. This is over our 10 ohm source, our 10 ohm resistor on this side. So what happens with our voltage source is it becomes 0 volts. So this is just a wire. And then we're left with our 100 ohms here. So we want to find V double prime, but this is set up with current, and this is set up really well for current divider. So in that case, what I'm going to be looking for is IXRX equal to IRE. So let's label our IX. We care about finding it over this source. Passive sign convention says that IX will go this way, from positive to negative. It'll go through the 10 ohm resistor. Our current will come out of here, and it'll go up this way, and it'll go up this way. That's just KCL. And so you'll see that the arrows don't match, which means that when we pull in the 1 amp, we need to add a negative sign. And then our equivalent resistance, we can find that by doing our parallel resistors. So I have 1 over 10 for this one, plus 1 over 100 for this one. The common is 100, so we'll get 10 plus 1 which will be 11 over 100. So our equivalent will be 100 over 11. So plugging that in, we'll get negative 100 over 11 when I plug in my 100 over 11 here. Solving for Ix, we'll get negative 100 over 110. Oops, let me slide that up for you. Now this is not done because this is Ix, and I want V double prime. So that's just an Ohm's law. So we just do a quick Ohm's law here. So Ohm's law just says that V double prime is equal to Ix times 10. Because I followed passive sign convention, my signs are all going to work out. So negative 100 over 110. So this is actually just negative 10 over 11, if you want to simplify that. And then what you'll get is that this becomes negative 100 over 11 volts. So it is a negative voltage. And that is the contribution from the current source. And then when you put them together, so if you come back up here, you'll find that the voltage V is 10 over 11, which was our V prime, plus a negative 100 over 11, which was from our current source. And when you put those together, you will get a negative 90 over 11, which simplifies down to roughly negative 8.18 volts. So in overall, the 1 amp source is causing more voltage than the 10 volt source.